Welcome, and thank you for watching. In this session, we will review the questions and solutions to exam number 2 for Math 1508, a pre-calculus course taught to students majoring in computer science and engineering at the University of Texas at El Paso. The following exam was designed and written by Dr. Alt Duval, also from the University of Texas at El Paso. Now, let's get straight to the fun. On exam number 2, we have a total of 6 questions. For number 1, worth 10 points. For each of the following simplification problems, show your steps. A, for 5 points. Find the exact value. Your answer should not include a logarithm of log base 3 of 9 to the negative 4. B, also for 5 points. Write e to the 3x times e to the 4y quantity over e to the z as the exponential of a single quantity. In other words, rewrite the expression so there is only a single e in it. Number 2, for 10 points, use long division to divide the following. The quantity 2x cubed minus 5x squared plus 5x plus 4 divided by the quantity x squared minus 3x plus 4. Number 3, for 12 points, solve for x in each of the following equations. You may have e and natural logarithm in your answers. Show your steps. 4 parts for a total of 3 points each. A, log base 2 of 5x equals 3. B, e to the x equals 17. C, 3 times the natural logarithm of the quantity 5x plus 1 is equal to 6. D, e to the x times e to the x minus 2 is equal to 15. Number 4, for 20 points, find any vertical and horizontal asymptotes for each of the following functions. Note that not every function will have both kinds of asymptotes. In each case, explain what you are doing. No explanation means no credit. A, for 10 points, f of x equals the quantity 2x minus 6 divided by the quantity x plus 5. B, for 5 points, g of x is equal to 40 divided by the quantity 1 plus 5 times e to the minus 2x. C, for 5 points, h of x is equal to 90 plus 40 divided by 1 plus 5 times e to the minus 2x. Number 5, for 10 points. A, for 2 points, an important logarithmic identity is log of base b of q times r is equal to blank for arbitrary positive quantities b, q, and r. Fill in the blank to show the other side of the identity. B, for 8 points. Explain why this identity is true. Your explanation should make sense to a classmate. Use complete sentences. And finally, number 6, for 10 points. An F-sharp program is shown below. It will plot the graph of y equals f of x. For what function? F of x. Your answer should be a formula entirely in terms of x. And the program follows. Now, to the solutions. Okay, for problem 1 we have the log of base 3 of 9 to the negative 4. Let us first recall a couple of items. First, that the log of base a of a is equal to 1. Also, recall that b to the m raised to the n is equal to b to the m times n. And one more thing is that the log of base b of a to the m, well, we can bring this m out and get m times log base b of a. Now, with that in mind, we can rewrite this logarithm as, well, the log of base 3 of 9 to the negative 4. Well, 9 is 3 times 3, or 3 squared. And we have this raised to the negative 4. And finally, from this rule right here, b to the m to the n, we can rewrite this as log base 3 of 3 to the 2 times negative 4, or simply 3 to the negative 8. We can then bring this negative 8 out, giving us negative 8 times log of base 3 of 3, but base 3 of 3 is just 1, so this becomes negative 8 times 1, or simply negative 8. And that's it. Now, For problem 1b, we wanted to write the following expression with only one e in it. We wanted to simplify. Well, here we should recall the following. b to the m times b to the n is equal to b to the m times n. And also b to the x divided by b to the y is equal to b to the x minus y, where of course b is not 0. Now, hence we can rewrite this as follows. Well, the numerator becomes e to the 3x plus 4y. This over e to the z. Now, this becomes, we've got e to the exponent in the numerator, which is 3x plus 4y, minus z. But because of the associative nature and commutative nature of real numbers, we can rewrite, we can drop the parentheses and simply write e to the 3x plus 4y minus z. And that's it. Now, problem 2, we wanted to use long division to divide the following expression. Well, first we rewrite this in the usual way, which is x squared minus 3x plus 4, and we're going to divide this into 2x cubed minus 5x squared plus 5x plus 4. Now, we want to take this leading term and multiply by something that will make it look just like this 2x cubed. Well, if we got that x squared there, we can multiply by 2x, and that would give us that number here. Oh, and I forgot, of course, an x here. So, corresponding to what we're going to multiply by, the 2x, that would go with 5x right here. So we write 2x, and now 2x times x squared, well, that's our 2x cubed. Then we have 2x times a negative 3x, well, that's a negative 6x squared. We have now 2x times 4, 2 times 4 is 8, so that gives us 8x. Now, we subtract, actually. And that gives us, 2x minus cubed minus 2x cubed is 0. 5x squared minus 6x squared is just x squared. 5x minus 8x is a minus 3x. And of course we bring down this plus 4. Now, what do we multiply this term, this leading coefficient here to give us a coefficient here? Well, if we multiply by 1, well, it turns out now that 1 times this polynomial expression right here is equal to this one right here. So we simply have 1 times x squared is x squared, 1 times a negative 3x is negative 3x, and 1 times 4 is 4. These match up, so when we do our subtraction right here, we get 0, which means this divides evenly. This expression right here, x squared minus 3x plus 4, divides even into x cubed, 2x cubed minus 5x squared plus 5x plus 4 with a 0 remainder, and basically that's it for that problem. Now, for problem 3a, we wanted to solve for x. So we have the log of base 2 of 5x is equal to 3. Well, let us recall the definition of logarithm. So by definition, the logarithm of base b of a is equal to x if and only if, by definition, b to the x is equal to a. b to the x is equal to a. So with that in mind, we can rewrite this by definition of logarithm as 2 to the third is equal to 5x. So we get 2 to the third is equal to 5x. x. And notice that's just this little circling here, just a little way to remember, at least for me. Now, 2 to the third is 8. This is equal to 5x. If we divide both sides by 5, we find that x is equal to 8 over 5. And that's it. Now, 3b. Well, 3b, we have e to the x is equal to 17. Well, something we can do here is we can take the natural logarithm of both sides. That would give us the natural logarithm of e to the x is equal to the natural logarithm of 17. By that exponent property we mentioned earlier, we can take this x out. This gives us x times ln e is equal to the natural logarithm of 17. Well, the natural logarithm of e, well, that's just 1. That leaving us with x is equal to the natural logarithm of 17. And that's it. Let's just take a quick look at this natural logarithm of e really quick. Well, the natural logarithm of e, well, the natural logarithm is simply defined as the log of base e. So we have the log of base e of e, which again we get that log of base a of a that we saw earlier. So this is just 1, and that's how that becomes 1. Now, problem 3c, we have 3 times the natural logarithm of the quantity 5x plus 1 is equal to 6. Well, first of all, what we should probably do is divide by this 3 right here. This would give us, after these divide out, the natural logarithm of 5x plus 1 is equal to 6 divided by 3, or just 2. Now, we can do the inverse operation of the logarithm, which is just e to the natural logarithm of 5x plus 1 is equal to e squared. This drops out the 5x plus 1, so we have 5x plus 1 is equal to e squared. We subtract 1 from both sides. This yields 5x is equal to e squared minus 1. Now, writing that up here, 5x equal to e squared minus 1, we can now divide by 5 on both sides. These 5's divide out, hence x is equal to e squared minus 1 divided by 5. And that's it for that one. Now, 3D. Well, we've got this some base to an exponent times some base to another exponent. Recall once again that b to the m times b to the n is equal to b to the m plus n. Hence this becomes, or we can rewrite this as e to the x plus x minus 2 is equal to e to the 15. This gives us e to the 2x minus 2 is equal to e to the 15. Well, we recall that one-to-one property of exponents. If we have b to the x is equal to b to the y, well, this is true if and only if x is equal to y. So right away, whether we took the natural logarithm of both sides or just notice this property right away, we can write 2x minus 2 is equal to 15. We add 2 to both sides, giving us 2x is equal to 17. And finally, after dividing both sides by 2, we get x is equal to 17 divided by 2. And that's basically it for that problem right there.